Which Python web framework is the best? Flask is considered the most popular beginner framework. Django is the most popular full-stack framework, offering the most functionality and is used by many companies in production. And FastAPI has only been around for 3 years, but it took the hearts of the Python developer community by storm, facilitating rapid development and offering a tremendous web app speed. When comparing Google Trends, Flask is on top, closely followed by Django, but FastAPI is rising quickly. Based on GitHub stars, Django is the winner, but also closely followed by Flask and FastAPI catching up quickly. And in the speed benchmark test, FastAPI is the clear winner, outperforming the other frameworks by a factor of 2 or even 3. So which one should you use? It's hard to give one clear recommendation because, as always, the answer depends. Each framework has its own strengths and weaknesses, and all of them are great. So in this video, I created the same to-do app with all 3 frameworks. In the process, you learn how to use each framework and hopefully get a better feel for the trade-offs between each of these. So in the end, you can make the best choice for your next project. The project we're going to build is a simple to-do app, providing functionality to add, update, and delete to-dos. For each app, you'll learn how to use a database, use HTML templates, and implement the API routes. So let's get started. Let's start with Flask. Flask is well established in the Python community. It is loved by beginners and experts for its simple syntax while still being capable of managing full-blown production-ready web apps. So let's see how to do it. First, I recommend to create a virtual environment and then activate it. Then we need to install Flask and also Flask SQL Alchemy to work with a database. Then we create one file app.py and import all classes and functions from Flask that we need. The convention is always to create an app instance with a double underscore name. And then creating a route is as simple as defining a function and using the appropriate decorator. Here we say app.get and then a simple / since this is our homepage. This would now display Hello World on the website. In order to use the database, we import SQL Alchemy. Now we have to set some configuration variables, for example the name or path to the database. Here we simply use a SQLite file. And then we create a database instance by using SQL Alchemy and passing the app to it. Now we create a model for the database, so we create a class to-do that inherits from db.model and we give it 3 columns with the appropriate data type. We want an ID, a title and a complete flag for the to-do item. And then we call db.createAll to create and initialize our database. Now, of course, we want to use this, so in the home route we call db.session.queryToDo to retrieve all to-do items. And then we use the render template function from Flask with a template file name and the to-do list as additional argument so that we can use it in the HTML code. Of course, we need to create the template, so we have to create a folder named templates and then a file that we call base.html. And here we can use normal HTML code that displays a form and all to-do items. Now what is special here are these curly braces with % characters. This is special Jinja 2 template syntax that basically allows us some Python-like logic. For example, we can have a for loop where we iterate over all to-dos and show the ID and title for each to-do. Then we have an if-else statement to check the complete flag and show the label in a different style. And then we also need closing statements for the if and also for the for loop. We also create 2 links that are the buttons to update and delete a to-do. And the important part is that the href points to the update and delete route for this particular to-do ID. Please note that these will be GET requests, which is not a best practice for updating and deleting data, but it works, and for simplicity I will use it like this. Now we go back to the app.py and can implement the remaining routes. First, let's create a route to add a new item. This has the app.post decorator, since it should be a post request. We get the title via request.form, and then we create a new to-do item and call db.session.add and commit the changes. As last step in here, I use the redirect function together with the URL for function to redirect and load the updated homepage. The update route works similar. Here we query the particular to-do item with the ID. Remember that we also specified the ID in the HTML code. Then we update the complete flag, commit the changes, and again redirect to the homepage. And the delete route is the very same code, except that here we delete the to-do. And that's it. 49 lines of code is all we need. Super simple and straightforward. This is where Flask really shines. It won't be that quick with the other 2 frameworks. Now to run the app, we can export the environment variables flask app equals app.py and flask env equals development to get hot reloading. And then we say flask run to start the development server. And now we can add new to-dos, update them, and also delete them. Next, let's use FastAPI. It's one of the fastest Python web frameworks out there right now. It also provides an easy syntax, allows for rapid development, and offers some more nice-to-have features like automatic interactive documentation and type validation. That's why developers love it, and it's rising so fast in popularity that I think it will soon catch up with Flask and Django. Let's create a new virtual environment for this project. Then we need to install FastAPI. We also need an ASGI server, for example Uvicorn. And for the template files and database support, we need Python Multipart, SQL Alchemy, and Jinja 2. These are essentially the same dependencies as we get with the Flask and Flask SQL installation. Here we create 3 files, app.py, models.py, and database.py. We need a little bit more code for each compared to Flask, and we want to maintain a clean project structure. The basic app will be very similar to before. We import FastAPI, create an app instance, and create a function that we decorate with app.get. Here we return a dictionary, which will be automatically converted to a JSON response. One cool thing to mention here is that we could also declare the function as asyncdef, since FastAPI supports asynchronous programming out of the box and allows for an extremely fast web app. But for simplicity, I'll stick with a normal function here. FastAPI heavily relies on type hints, so if we want a dynamic route, we use this syntax. We put the argument in curly braces in the route, and then we use the same name as function argument together with a type hint. In this case, it should be an integer. This is concise, reduces bugs, and gives us automatic type checking, which we will see later. So let's continue with our to-do app. We need a few more imports from FastAPI. We also import a few requirements from Starlet. This is the ASGI framework that FastAPI is built on top of. Then we specify our template directory and use a template response in the home function. We pass the request as argument and also the database, which is a session object that depends on another function. Don't worry about this syntax yet, it will become clear in a moment. But note that again for each argument we are using type hints here. And then again we query the database for all to-dos and return a template response that needs the HTML file, the request, and the to-do list. In this case, the arguments for the template file are passed as dictionary. Now we also create a template directory and the base.html file. And here we can use the exact same code as before, since we are also using Jinja 2 templating syntax. Now let's set up the database. We get the imports and set up the path to the SQLite database. Then we need to create an engine. We also need to create a session instance. And lastly, we declare the base class from which the model will inherit in the next step. For the model, we import the database and this base class we just declared. And then we create a to-do class that looks very similar to the one from the Flask app, but now we inherit from base. Then we define a table name and use the same fields as before. Now we can go back to app.py and make use of all of this. We import the session class so we can use it as type hint. We import the models, the session local object, and the engine. Then we create all database tables, and then we create a helper function to access the data by session. This will now be passed to the home function as a dependency, which means if the database cannot be accessed, then also the request to this route throws an error. And this is already handled for us by FastAPI. So you can see we need a little bit more code here, but in return we get a lot more functionality already and a safer code. Now inside the function we can use the session object and query the database with the same syntax as in the Flask app. Let's continue and add the add route, which must be a post request. As parameter, we also use the request and the database, and now as new argument we also put in the title, which is a string that comes from the form. And then again we create a new to-do, add it to the database and commit the change. And then I get the URL of the homepage and return a redirect response. I also specify a particular status code which is needed because we now change from a post route to a get route. Very similar, we now add the update route, and as mentioned before, we use the to-do ID as dynamic argument with a type hint. Then we query the to-do, change the complete flag, commit the change, and again redirect to the homepage. And finally, we use the same code for the delete route, but here we delete the to-do item. And that's it. We can now start a server by saying uvicorn app::app The first is the file name and the second is the app instance. We also use ---- reload while we are in development mode, and then we can go to this address and have a working to-do app. One more cool feature we also get out of the box with Fast API is automatic API documentation. So we can go to the /docs route, and here we see all the different API endpoints together with the type. For example, we can click on the add post endpoint and then we see more details like that it needs a title as string. We can also try this out, enter a title and execute the command. And then we can inspect the results. So here we see we get the response code 200, so all is good. And we see the raw template response that is visible on the page. We could also try another route, so let's test the update route. This needs a to-do ID as integer, so if we try to send a string here, then it wouldn't let us. And on the page we would see an error code. And again, all of this is handled for us by Fast API, and this is possible because we use the type hints. Alright, and that's the to-do app with Fast API. I hope I could demonstrate some of the cool features here. Now for the final app we use Django. While Flask and Fast API are considered to be more like a micro framework, Django is a full stack framework with many batteries included. It's the backend framework of choice for many Fortune 500 companies. While the learning curve might be steeper than with the others, it offers so many features that it makes your life easier once you know your way around it. Again, I start by creating and activating a virtual environment. Then we only need to say pip install Django. This comes with all the requirements that we need. Now we say Django admin start project and give it the name to-do app. This creates a new folder, and inside the folder we have the manage.py file and another subfolder with the same name and all the starter files we need. We cd into the first folder and can run python manage.py run server. This starts the server and we have the initial app up and running. For now we quit the server again and say python manage.py start app and the name to-do list. An app is a component inside a project that is responsible for certain things, like here for managing the to-dos. In this simple project, this is the only app we need, but imagine if we add authentication, then we could put this in another app to keep the logic separate and clean. After creating an app, we also need to add the app name to the installed apps in the settings.py file. Now we want to add the views, so inside todolist.viewspy we add a function that gets a request, and then we return the render function with a template name and as dictionary all items we want to pass. The missing to-do part will be implemented in a moment. For each view, we need to register a URL, so we create a urls.py file inside the to-do list folder, import the path function, the views module, and then we define all URL patterns we want to add. In this case, we leave the route of the path empty, since this is our home page, and then we use the corresponding function and can also give it a name. Now we go to the to-do app.urls.py and use the include function to include all URLs from the to-do list app. You can see that there already exists an admin path. This is because Django gives us an admin panel out of the box, which we will see in a moment. Now we will need to create the template file, so let's create a new templates folder in the top directory, and then we again create the base HTML file and put in the same code. Django uses its own templating language, which is similar but slightly different than the Jinja 2 template, but in this case we only have a for loop and an if statement, and this is actually the very same syntax. But there is one thing we need to change. In the form part, we need to add the CSRF token. This is a security mechanism that prevents attacks to the form, but we don't need to do more than adding this here. Now we need to go back to the settings.py and add the templates folder to the directories key. Now we implement the model class. So inside the to-do list models.py, we create a class that inherits from models.model, and then we again create the same fields with the correct data type. And we also implement the string method to see an accurate description. Here we don't need to create an ID since Django does this for us. Now in the console we say python manage.py make migrations followed by python manage.py migrate. Then we also create a super user because I want to show you the admin panel. So we say python manage.py create super user. We follow the instructions and put in a name, an email and the password. As next step we go to the admin.py and register the to-do model. And now we go back to the views.py, import the to-do class and then query all to-dos in the index function. Let's run the server again and test this. We see the home page with 0 to-dos for now. If we click on the Add button, we get an error since we haven't implemented this view yet. But one cool feature that is already available is the admin panel. So if we go to the /admin route, we can log in with the super user we created. And here we can see different groups and users if we would add authentication. We also see the to-do models with all the fields we specified. And here we can interact with our database. So we could add or modify the database entries right from the admin panel. This is one very cool built-in feature that you don't get with the other frameworks. So now let's log out again and implement the missing views. So we import 2 more functions and then implement the add route. We require that this should be a post method by using this decorator. We could also check the type of the request inside the function, but I wanted to show you this second way of doing it. Inside the function, we then create and save a new to-do and redirect to the index page. Now we implement the update function. This gets an additional parameter to-do ID, which is then be used to query for this to-do, and then we change the complete flag and save it, and again redirect. The syntax for working with Django models is slightly different than before, but in my opinion it's even more simple and straightforward. And the last view we need is the delete view, which is very similar, but here we delete the to-do. And now we only need to add all these views to the urls.py. So in here we add all the paths with the corresponding route and view function. We can use this syntax with a data type and parameter name to add dynamic views. And that's it. We can now go back to our app and we should be able to add new to-dos and then update and delete them. Awesome. Alright, that's it. You can find the code for all apps on GitHub. The link is in the description. This video was a lot of work, so if you enjoyed it, please hit the like button. I'm also interested to hear what's your favorite framework, so please leave me a comment below. And as always, I hope to see you in the next video. Bye!